My name is Amanda Mahaffey. I am Deputy Director of the Forest Stewards Guild, and I get to organize workshops and webinars for the North Atlantic Fire Science Exchange. This webinar today is part of a prescribed fire science virtual workshop series, and you're going to get to learn a lot about the fire ecology of New Jersey, fire ecology and fire history of New Jersey from some people that know it really darn well. I'm going to let them introduce themselves, but so for today, I'm thinking of this as more of a panel. They do a PowerPoint. But they're also really eager to answer your questions. So please use the chat window to type any questions that you have. And we're going to get rocking and rolling. So Inga, you are up first. Please introduce yourself, and anybody who has questions, please type them into the chat window. We're going to address them after the presentation concludes, but I'll be keeping track of everybody's questions as we get going. So thank you.
Okay. Can you hear me, Amanda? All right, so my name's Inga Puma, and I am the technical lead for the land fire program with the USGS. But I've just kind of transitioned over from a job working with the Fire Science Exchange for the last 5 years with Amanda and Nick and Aaron. So I know a lot of the folks from the Northeast. And, you know, one of my claims to fame, as you'll see coming up, is that I've worked on the fire history of New Jersey for quite some time. Tom, did you want to go ahead and introduce yourself?
Yes, so Tom Gerber. I am a 40-year fire manager with the New Jersey Forest Fire Service, a lifelong Pine Barrens resident. My family goes back in this region a couple of centuries.
All right, so we're going to get started. We're going to go kind of a landscape level fire history and ecology in New Jersey, and just kind of walk you through some of the major points of what's happening in the Pinelands here. So Tom, you want to talk about these images here?
Sure. So the New Jersey Pine Barrens, you see on the map on the screen there, it's a 7-county area, spans 7 counties in southern 2/3 of the state. It's about a 1.2 million acre region, somewhat sparsely developed, but has developed, you know, quite a bit here in the last several years. But we're going to talk about what has kind of shaped the Pine Barrens forest that we see today. And it was largely shaped by events in the 18th and 19th century. In the 18th century, the Europeans were coming in large numbers to the New Jersey area. They were settling in New Jersey. And some of the early people that settled in like Pennsylvania area and all had started the iron industry in Pennsylvania. And they saw all this large amount of forest land in South Jersey, and there were lots of rivers and waterways that could be dammed for sawmills and for iron furnaces and such. So the iron industry of the early 18th century required huge amounts of timber to power the iron furnaces and forges. And so it's been estimated that in some cases, these furnaces and forges would require upwards of 40 and 50,000 acres of forest land to supply the furnaces in the region. And in the heart of what we see of the Pinelands, there were, you know, sometimes as many as 10 iron furnaces that were in production during the late 1700s, up until about 1845, when they were beginning to go in decline. So wherever they could find bog ore, and it could be mined, it could be moved with water, they had the timber there available. So these forests were, like I say, they were repeatedly cut over. During that same time period, the 18th, 19th century period, the forests were cut over repeatedly. A lot of the furnace diaries talk about, you know, fires during the spring of the year, or in the summer drought period. So these forests were constantly in a state of evolution. They were being cut, they were being burned in wildfires. So there wasn't a lot of vegetation. You know, they were being cut every 30 years. So this continued then the glass industries came in the 1850s. In that time period, the railroads, there were more fires on the landscape. And this was just becoming, quite a area of fire prone. And in the 1895 era, whole towns that had sprung up in the Pine Barrens were being burned over. And about that same time frame, the state had commissioned the state geologist report. And in 1898, he said it was impractical to build any towns or anything until they get a handle on this fire problem. So this continues. 1898, disastrous fires, and kind of goes into the early 20th century. Still, things are really bad around the turn of the 20th century. As we get towards the 1920s, some organized fire control was coming forward from the recommendations of the U.S. Forest Service. A forest fire service is established in 1905, and a warden's system was put in place where fire wardens were covering these areas of the Pinelands. But still, disastrous fires are occurring. This disturbance is going on. Huge fires in 1930, in May of 1930, 250,000 acres burned. I was just reviewing some old air photos from 1932. And when you look at this Pine Barrens area, a lot of what you see on the screen, the areas where the iron furnaces and all these large fires, a lot of it appears as, just open sandy areas. There's hardly any trees at all. May of 1930, then you go into 1941, disastrous fire years. Towns burned to the ground, Forked River as such. In the area that I cover here around the Medford Lakes area, several homes are destroyed, which leads up into 1954. A fire is chronicled. It's called the Chatsworth Fire of 1954. It only burns 20,000 acres, but the people are so alarmed. It's a summer drought fire, and when a wind event came through with 70-mile-per-hour+ winds, the entire 20,000 acres lit up during the midnight hour of July 12, 1954, and the residents were terrified that lived in the heart of the pines in the Chatsworth area. So that was another benchmark fire, followed by, at that time, the state of New Jersey was beginning to acquire large tracts of land for the protection of the 17 trillion gallons of water that are underneath of the pine forest in what's called the Cohansey Aquifer. So the state begins acquiring large tracts of land, the Wharton State Forest, the largest forest at that time east of the Mississippi River, over 100,000 acres, was acquired in 1954 and 1955 with the idea of protecting that water supply. Along with that, the Forest Fire Service began doing control burns on large landscape scale. The Wharton Forest in that early time period, 1954, 1955, was burning in the neighborhood of 7,000 acres, which was an astonishing amount of prescribed burning for that time period. But the forest had come off of all those fires from the 30s, 40s, and 50s. The fire return intervals at that time were somewhere around 7 to 15 years. Every 7 to 15 years, there was a major fire occurring on the landscape. So that moved forward, fast forward to the year of all years, 1963, when a series of fires on April 20th through 22nd of 1963 burned over 200,000 acres, 400 homes and buildings, and unfortunately 7 lives were lost. So 1963 was the benchmark year in the 20th century fire, and a lot of things that are going to be talked about later. Cy Little was commissioned to do a report for the New Jersey Forest Fire Service on, heading towards better motorized fire protection, more motorized equipment to effectively knock these fires down when they're small, which took us through to probably one of the last bad years of multiple fires, 1977, March 31st. Wind-driven events, 54-mile-an-hour winds, 13 major fires in one day. The only difference being from the 200,000 acre era, only 20,000 acres burned in those 13 major fires. So from that time period, you know, a lot of things have went on, and you know, the 1980s and 90s, a lot of laws were passed to make it a serious crime for starting fires. Most of the fires are human caused here in the Pine Barrens. Unfortunately, a lot of those at the time were incendiary, which means, you know, they were intentionally set for, you know, to berry pickers, to increase crops of huckleberries. There were a lot of fire problems. So in the early 90s, laws were enacted to make it a serious crime for starting a forest fire. And so that kind of brings us to the era where we are now. The return interval for fire in the Pinelands tends to run upwards of 30 years, and we are seeing a maturing forest that probably most people alive haven't seen. So we have a lot of things going on.
That was awesome. So yeah, just to kind of build on what Tom was saying, you know, this is a landscape that's seen a lot of fire compared to other places in New Jersey and the Northeast. So you can see here, there's some areas that kind of pop out as burning more. These are all the wildfires that we've recorded between 24 and 2017. So, and these areas are what we call the dwarf pine plains, and we'll talk a little bit more about that. But you can see there's not a lot that hasn't burned since 1924. And then here, you know, you can see I was pointing out some of the yellow from 1963 that burned, so it was a lot during that time period. And then you can see some of the more recent fires. Also the Spring Hill fire, which we're going to talk about, is not on this map, but it would be right around here. So that would be another part that would be red on the map as a more recent fire. And if you're talking about sort of the more recent fire history, you can see that spike in 1963 here. But not, you know, ever since then, it's kind of stayed around, you know, our largest one's getting to around 20,000 acres. So that seems to be kind of our maximum lately. Then we talked about the season. Well, here you see April 20th is when the most acres burn in terms of our season, but it's a nice little bell curve around that. Then you see you know, some summer stuff here, but mostly it's that early spring time when you know, things have dried out, and other people know a lot more about the spring dip phenomena that we see in the foliar moisture of the pitch pine there. And pitch pine is our major species in the Pinelands, and this is the area that Tom was talking about that's been protected, the Pinelands preservation area, and you know, there's various rules about what can be done within this area in terms of the land use. And do you want to talk a little bit more about that, Tom?
Yeah, so it's interesting to note that, you know, a lot of changes in my 40 years. We went from, you know, a tremendous arson fire problem that began to correct itself after a large 20,000 acre wildfire in Ocean County when the law was passed that, you know, if we could prove you started a fire, then, you know, you would go to jail for 5 years. So cut down a lot of the incendiary fires. So we got a lot of changes there. So most everything that's occurring now is accidental in nature. Lightning's still about 1%. We're still somewhere in the neighborhood of about 1,500 forest fires statewide, and probably 2/3 of those are in the Pinelands region. In regards to prescribed fire in the 50s, 1954, when all the land acquisition was going on with Wharton Forest, the forest was primarily being managed for the growth of pine. So the traditional burning on upland pine oak sites with a backing fire, that was the norm right on up until about the mid-1980s. Myself and a couple of other managers were looking around. It's like, you know, we've got a pretty good handle on prescribed fire in these 5 to 6 year rotation burns on upland pine oak sites. How about if we look into that dwarf pine area, a lot of the doghair pine, immature pine less than 20 feet tall, that was largely sculpted by the 54 and 1963 fires. So we began to feel our way into doing some burns, taking advantage of natural breaks, some of the wetland areas of the Pinelands, and we were more able to mimic a little bit more of a heading fire and you know, bring some of these forests that before were never control burned after these large wildfires, because it was just, there was no way to get mechanized equipment in to plow lines. So we started entertaining, taking advantage of the natural break. So we've been able to cover a lot of real estate in the core of the pines in some of those old burn scars.
All right, so I just wanted to show some of the fire effects of the wildfire anyways. And so you can see for our pitch pine, it has the epicormic shoots. And so what happens is that it just sort of like sprouts all over the place. And depending on the severity of the fire, you know, that'll kind of determine how much it resprouts. And then if the fire is a little more severe, then it just does this basal resprouting. And then you can see here that I didn't have a photo of it, but it's got the serotinous cones in some areas more than others. Basically where there's been a higher fire frequency in the past, you have more of the serotinous cones where the seeds will release when they encounter heat. And there is also sort of this mineral soil requirement for the seedlings to sprout. So you can see that this is sand, you know, the Pinelands is almost entirely sand. So did you want to talk about the doghair pine there, Tom?
Yeah, so very typical of these, you know, crown consuming fires and all, everything comes back, you know, the density, you know, just brings all this sprouting and, you know, until there's a future disturbance, which was typical every 7 to 15 years, they would doghair and there would be you know, a heading fire, a major fire would run through them. But very typically, you know, they're stand replacement fires, and you know, they just come back that way. And
so
very difficult to backfire through when you're doing backing fire in traditional prescribed fire.
I guess just to be a little more clear about the doghair, it's just like extremely dense, very you know, small stems of the pitch pine coming back, I guess how would you describe that? It's just, it's like, looks like dog hair of pine, like everywhere. Yeah.
It does, and you know, and now that we're seeing the longer return intervals, the height is increasing in not only the dwarf pine forest, it's increasing in you know, in the pine lowland areas. So now, you know, where most of my early career, the forest was in much more of a immature state, you know, scrubbier state. Now we have trees that are much taller, producing larger crown fires with that bulk density.
Okay,
hey,
so we're running over, huh?
Yeah, if you could just quickly show some of those historical photos, then we can get a look at what some of this dog hair and what conditions look like historically.
So take note on the picture to the right. Very often I've you know, read over a lot of the major fire reports from the early years, and most of the larger fires during that time, the wardens would talk about steering them into that vast wasteland known as the Pine Plains. fires were, at that time period, they were easier to manage. They were lots of times sanded out with shovels and brooms and such. So
Yeah.
a lot of times the fires were steered away from valuable town areas into that plains.
Yeah, so that could be contributing to why it has a higher fire frequency anyways. One of the things that we wanted to talk about was how things are getting a little bit taller in the dwarf pine plains. And so this is something that Tim Warner from West Virginia University put together, where in the yellow, this is the dwarf pine plains area outline, and you can see the blue is 3 meters height. So this is taken from LIDAR data, where back in 2004, the highest was around that 3 meter height, and then now it's sort of shifting, and or at least in 2015 is shifting to be a little bit higher for the median of the height in the pine plains. So you can see when there's less fire there, the structure is going to change. And so that's kind of what that's about. And we can see some of that now too. And I just wanted to quickly mention the Spring Hill fire that we are all going to look at in depth a little bit more with some of the modeling. This was a fire that occurred in that same area in 1946 that came from that fire history. So it's seen fire many times before. These are all the fire frequency in the area. Quickly, so Tom was talking about the different causes of ignitions, and we have incendiary is really high up there. Unknown is also very high up there. Railroad was really big in the 20s and 30s, sparks from the railroad. So, and then you can see over here lightning. So that's your 1%. But also you can see that there's not a lot of ignitions happening right where the Pinelands are. And they're happening mostly around the edges, but this is where the fuel is. And the wildfire hazard potential, you can see if you look out in California, you've got these bright red areas, but if you zoom in on New Jersey, we have our own sort of bright red high wildfire hazard potential from the FSIM runs. And here's a little bit with the prescribed fire history in Division B. So you can see that it's pretty extensive in the area. And this is Wharton over here, Tom? Yeah.
Yes.
So this is the Wharton area. So I'm sure there's more to that history as well. And this is just showing a section near in that Wharton area that's showing the wildfire, prescribed fire, and then both. So these areas all combined. And when we looked at pitch pine uplands in particular, there really wasn't anything on the landscape that hadn't been burned since 1924. So just to show you that this area is, it's very much got fire everywhere. I think that's all I have, Amanda.
Great,
do you have
thank
anything
you.
to add at the end there, Tom?
No, I think that was wonderful.
All right, let's let Mike load up his presentation. So just a quick recap, if you're not familiar with the New Jersey Pine Barrens, they burn, they have burned, and they pretty much always are going to burn. Fuels and the forest structure have changed over time. And actually, fortunately, there's been a lot of fire science studying a lot of things. I'm not going to steal Mike's thunder, but you're going to hear a little bit about the fire science that's also been a part of the history in New Jersey. So whenever Mike is ready, and just again, if you have questions, please feel free to type them into the chat box, and we'll address them as soon as the presentation concludes. So, Mike, don't forget to introduce yourself briefly.
Great. Hi, I'm Mike Gallagher. I'm a research ecologist with the U.S. Forest Service Northern Research Station, located here in the Pine Barrens. Can you see my screen right now?
Yep, it looks great.
Okay, excellent. So the New Jersey Pine Barrens has a long, interesting history of fire research that really starts with Gifford Pinchot in the 1890s. As Tom mentioned, there was a large fire problem that had evolved at that time out of the, I guess, the effects of the iron industry and glass industries in the Pine Barrens that had left a very scrubby, widespread fuel across the region. And so these fires were burning annually, upwards of 100,000 acres a year or more, and the state needed justification to do something to put them out. And they got the Division of Forestry, this predated the Forest Service, to send Gifford Pinchot to the Pine Barrens to do an assessment of fire effects and what they meant in terms of the landscape. These are some of the scenes that Pinchot saw during his visit of the degraded forest and the heavily burnt forest. And today, actually, after a really severe fire, it doesn't look so much different, although there wouldn't be as much sand because we've got a lot more duff accumulation than there probably was then. Pinchot also saw some forests that he thought were original growth or second growth forests. And they reminded him of when he had been in France and saw some beautiful managed forests along the dunes of the west coast of France. And so he saw a lot of potential in the Pine Barrens and what it could be in terms of timber and managed land if we just got this fire problem under control. So that report that he published in the 1899 State Geologist Report really helped justify the beginning of New Jersey Forest Fire Service in 1906. And so that was the first research, really. It was very qualitative. He talked a little bit about the economics, but that really helped justify the state's expenditure for an organized firefighting organization. And they set up lookout towers and staffed the forest with Tom's predecessors, who were the early section wardens, to respond in an organized manner to put out fires effectively. But after about 20 years, by 1926, the number of fires was still pretty substantial. You can see on the figure on the left, that's kind of the same one that Inga had before, but just looking at those first 20 years of Forest Fire Service, the acreage was still increasing. And Forest Fire Service was not well funded at that point. And the first chief of the Forest Service, Colonel Coyle, actually wrote an article in the Journal of Forestry about the importance of funding forest fire programs and the value of doing that. And it might be hard to imagine, but forestry was still very controversial, and forest fire management and forest management were extremely debated in the literature at the time. But New Jersey, you can clearly see, had the largest amount of fire in the eastern United States. And I don't have them here, but I found some numbers. Compared to today, the West Coast was hardly burning at all. And so in 1927, the Allegheny Experiment Station, which is the predecessor of my organization, the Northern Research Station, was formed in Philadelphia. They had 7 staff, and one of them was sent to the Pine Barrens to establish the Camp Ockinickon headquarters, which is here in Medford, Tom's section. And they worked with the local section wardens of Forest Fire Service to learn more about the fire problem. And they worked with the state foresters to conduct research that would inform better land management. That's a picture of the cabin that was at Camp Ockinickon that's moved down the road and still at the current field station, the research station. So this early research involved documenting how fire breaks were useful for stopping fires. It's kind of funny to think that they would need to justify that, but they did at the time, and how they'd be important for restoring and managing future fires. This is a picture left and right, before and after, of fuels management. I wouldn't call it mechanical thinning. This was human labor to thin safety strips that help slow fires that might occur and give a place to make a stand. Here's an example of what things might have looked like without a safety strip and with the safety strip. And you can see that there's still pine needles on the trees after a fire that burned a safety strip. This is an example. Inga and Tom mentioned the 1930 fire. This is an example of one of the early fire effects plots that we had that was in that 1930 fire. And they were looking at how forests regenerated after burning at that time. In 1937, prescribed fire was begun at a landscape scale with Forest Fire Service. Farmers had been using it frequently prior to that, but the state began its own organized prescribed burning program, and with that, Silas Little began studying the effects of prescribed burning and repeated burns and how that affected pine regeneration and fuels over time. And he was able to demonstrate with the figure on the right that multiple burns would increasingly reduce the fuel load at the forest floor, but also create good conditions to regenerate better structured pines. In the 50s, like Tom said, prescribed burning increased, and they used some of the research to justify repeated burning. Not everyone understood that it wasn't okay just to burn it once and forget about it for forever. And so you can see in the 1950s, on this figure, the acreage burn really starts to go down, with the exception of that 1963 fire and a couple other years. Here's an example of a prescribed burned area and one that wasn't prescribed burned at the research station. There were two fires in 46 and 63 that nearly took out the research station, and the saving of the research station was credited to winter prescribed burning that had been done almost immediately before the wildfires. So fast forward into the future, and here's the research team. It's a mix of forest fire wardens on the left. You've got Nick and I are in the middle there, and then the other folks are from the University of Edinburgh, and Ken Clark's there on the right too, also one of the research staff at the experimental forest. And together we've been doing some neat new things with research. In the 1930s, they were using height and diameter to estimate the volume of a tree and develop curves for foresters. And now we can use LIDAR to look at the three-dimensional distribution of fuels, look at how they're distributed around homes to reflect who actually owns fuel hazard, and look at how those fuels relate to fire effects across a landscape when they're burned. That map on the right, the colors show a gradient of fire effects in a 3,000 acre prescribed burn project and a wildfire on the north, and how they were varied. These projects also really hinge on this long-term relationship with Forest Fire Service, and they've really been an awesome organization to work together with to organize, to come up with some of our research ideas, particularly about embers, and to conduct projects where we can basically piggyback on their prescribed fire projects and study things like smoke emissions, fuel consumption, and heterogeneity of fire behavior, or how that fire behavior varies with different winds and fuels and ignition patterns. One neat thing that's come out recently is some more information about how pitch pine bark flakes and actually longleaf pine bark flakes are an important component of ember production in the eastern United States. So I'm just going to summarize my part here, or close it out. Here's a list. This year we've published over 22 products about forests and mostly about fire using the field station in the Pine Barrens here. And that all began kind of with this picture on the upper left. That's a picture of Gifford Pinchot, second to the left, at the Lee Brothers property in Speedwell, New Jersey, in the Pine Barrens. And they're staying there with Governor Scott in 1894. And Gifford Pinchot became friends with some of the folks of the Pine Barrens, particularly the Lee Brothers, and would stay with them, or the Lee Brothers' grandfather, when he came to visit the Pine Barrens. And today, we have a good relationship with the Lee Brothers. We actually have a couple research plots on their property, and continue to work between that public land with the state and private landowners to conduct research together. Now Nick will give his part.
All right. Hi, everybody. I'm going to play cleanup hitter here and go back to that one. There you go, Mike. And we're going to not share it on my screen. We're just going to stick with Mike. So my name is Nick Skowronski. I'm a research forester also with Mike and Ken Clark at the Northern Research Station, the U.S. Forest Service. I spent my formative years of my career at the Silas Little Experimental Forest, and I still do much of my field work in New Jersey in the Pine Barrens, someplace or another. So I want to just sort of briefly go into why we're here today and for the rest of the week, and then why are we still doing research in the Pine Barrens, and where is that all leading to? Okay, so Mike just did a very good job of discussing the history of research in the Pine Barrens, following Inga and Tommy's explanation of why fire is a process and why it's important in the Pine Barrens. I think that we've
Hey, Nick, sorry to cut in. You sound a little bit muffled. Can you just double check your mic real quick?
Yeah, it's just is what it is, Amanda. I'll move a little closer.
All right, thanks.
Yep, sure thing. And so the reason that we have sort of redoubled our efforts to do research in the Pine Barrens is because of the simple fuel structure that you've all sort of seen as these talks have gone on. The species assemblage is basically a gradient between some percentage of pine to some percentage of oak, and really just the same species for the most part mixed in there in some different component mixture. We also have very simple topography. It's a very low level of relief going on in the Pine Barrens, and there's a lot of fire on the ground. And so it's really kind of an ideal place for folks to do sort of fundamental physical fire research, and to also sort of a model for us for the types of things that we want to study as far as fire management goes and the effects of that fire management on the landscape. And the other reason, and this is maybe the most important reason why the relationship in New Jersey is working so well, or why the research has progressed to the point that it has, is because our work there has always been focused on a foundation of scientists and managers working together on research problems. So we're all in the same room and we're all discussing these things back and forth, whether it's in a formal setting like is shown on the screen here, or whether it is getting coffee in the morning and integrating that way, or spending time together on the fire line. And so I think that we've really kind of fostered this idea of co-production and really implemented it in our research and in what's going on in the Pine Barrens right now as far as both fire management and fire research. Mike, can you switch to the next slide, please? And so we spend a lot of time in these situations talking about the issues that are important to fire managers, and also they spend a lot of time listening to us explaining to them the issues that we feel are important for fire science and fire management in general, and not just in New Jersey. And I think that one of the more fundamental things that have come out of this is a basic trust between the fire managers and the fire scientists, that we are working towards their problems, but I think that they also understand that the work and support that they're giving us through fireline experimentation or conversations, I think that there's an understanding that that work is going to be transferred into things down the line in the future, including the production of sort of models or theory that they know that they might not necessarily see within the time frame of their career. Next slide, Mike. And I think that early in sort of the reestablishment of the research program in New Jersey, there was a lot of give and take, and we worked very hard and diligently to give actual products to the fire managers that they were able to use originally and right away. You can see in the top right-hand corner here is a fire danger monitoring console. This is what Ken Clark's work about 20 years ago now, where we identified a spot in the Pine Barrens that really didn't have, most of the Pine Barrens that didn't have simple things like meteorological measurements. And we were able to use our research grade equipment to basically fill that gap and then provide that data to fire managers in real time at a time where it was really kind of difficult to do that, given the lack of the internet at that time. So that was sort of an early buy-in thing that we had done with the state. It also sort of hinged on the interpersonal relationships and several individuals that had allowed us to carry through with our work. Maris Gablis was the fire management, or the chief fire warden at that time, along with Steve Maurer as the deputy. And when we first started, we had a spirit of collaboration that they gave us that allowed us to really integrate with the Forest Fire Service and to become a part of that organization as well as being researchers. That's really carried through the years with Bill Edwards and now with Greg McLaughlin. and the other fire wardens in the interim there as well. We had support, we had backing, because they knew that we were trying to help them while we were doing other things. So as time went on, Mike, can you switch sides? Next slide. There you go. As time's gone on, we've able to sort of take some of our sort of more fundamental research and almost methods development work and to really apply it to questions of how fire is managed and how maybe prescribed fire might be representing the forest a little differently in this case, using LiDAR for the entire Pine Barrens region. This is a repeat of what Inga showed. And this graph in the middle basically shows how multiple wildfires are increasing fuel loads in the understory. So the photo on the left would be a wildfire stand, and that prescribed fires are doing basically the opposite, right? So we have a lot less understory, but we're actually seeing some growth in the overstory. So this is sort of this integration of the science that we're interested in for the landscape, developing our methods, and then being able to hand this product back to the state. Mike, another one, please. So even though this operational research is kind of desired, it does take a while. And the funding sort of environment right now is such that we've been looking much more into fundamental studies of fire behavior, fire effects, and fire dynamics. And so at this point, one of the real beautiful things that's been going on is that we're able to conduct on the ground fire line experimentation with an understanding from the scientists and the researchers that this isn't going to be things that are integrated into management directly at any time in the near future. Mike, next slide. Next slide, Mike. There you go. And so these are a couple examples here. This was an ember study, and this was a block that we burned basically to capture and characterize the dynamics of embers coming from the fire. Very, very fundamental research, but with a very distinct application in the future as it gets tied into models that are modeling ember transport and fire line, fire break widths, and things of that nature, which is kind of funny considering Cy Little was doing that 80 years ago as well. Next slide, Mike. Okay, and so this is just another example of how we're making fundamental measurements that are getting integrated into models moving forward. And so the whole idea here is that you can see that the idea of this workshop is actually to sort of demonstrate where some of this research has been started to being integrated into more dynamic models of fire behavior and allowing us to basically game the system to see what our management operations might do, playing backwards on the fundamental research that we've gained or gathered, and all of the other folks around the country that are doing the same as they're integrated into these models of fire spread and behavior. So as this workshop sort of moves forward, I want to kind of point out that we're actually co-producing science as we do these sessions tomorrow and on Thursday. Basically, the modelers, the modeling community that we have assembled to help us out here are going to be presenting some scenarios to you all that we've helped them to sort of design and show and highlight the capabilities of the model that we're going to be working with. And it's really up to you guys to sort of maybe educate them a little bit on the things that you see that maybe the model is misrepresenting, and also the kinds of things that you might see yourselves using these models for in your management. And so in that sort of spirit, it really will be, you know, us integrating science and management together as we iteratively move through these models. So we're pretty psyched about that. Amanda?
Awesome. Thank you, Nick. Thanks, everybody. Yeah, just to be fair, we were originally planning on doing a day-long field trip to have all of our workshop participants get to see the New Jersey Pine Barrens from west to east. I really appreciate my speakers being willing to try to squeeze all that information into just an hour. Thankfully, we have some time for questions, and we've had some really good ones come into the chat window. Carlos had asked a question a little bit back. I think this one's for Tom. He asked, is the number of laws increase and decrease with the number of fires? In Portugal, it's usual to have lots of fires, lots of laws, and after that, less fires, and people forget about the laws. So, Tom, do you want to just, I know you talked about it a little bit, but can you just briefly mention about fire laws and how well they're sort of followed in New Jersey?
So, yeah, so it's interesting, the the arson law has resulted in a reduction of incendiary fires. So after, 10, 15 years, now we're seeing, a host of different fire causes. We're seeing a lot of machine use from miscellaneous causes, electric wires, etc. And then in light of the COVID, we're seeing a lot of burns in backyards. A lot of people wanting to have campfires, fires. So we're seeing fire causes as a result of open burning, which in most cases was banned many years ago. But we do allow people to have campfires and such. So in that respect, kind of they obey the law, but there is more fire in the landscape in these developed settings.
Cool, thanks, Tom. Ken Clark had a question and maybe an answer as well. He was thinking, as the climate warms and we seem to be experiencing less snow, will the peak in wildfires shift forward into the late winter? It would be interesting to look at changes in the seasonality of pine live fuel moisture. So if anybody on our panel wants to address that, I invite you to.
It's kind of a loaded question for Ken.
There's a number of factors that are involved there. One of the reasons for our spring fire season is the lack of leaves on the deciduous trees and the seasonal winds that really push fires. There's a lot more solar radiation that penetrates the forest floor, drying out the forest floor fuels and warming them. And that wind is really important. Those fluid dynamics of the forest are becoming a big part of our research right now and down the road. So I think phenology is important and how that plays out. Another factor that might be important is how snow packs the litter layer or doesn't pack the litter layer over the winter. One of the, we talked about this co-production over time, and one of the comments that came from some fire managers and that had been passed down to them from previous generations was about how they thought that when there wasn't as much snow in the winter, the leaf litter seemed a bit fluffier and to stay drier and to burn hotter in the spring. And if there's greater flow through that leaf litter and less compaction, you could think about burning like trying to burn a whole telephone book or all of its pages ripped out and crumpled up and fluffy. Which one's going to burn better? And
I have
so
a little chart that shows how things have changed seasonally. So these are sort of like the first 10 years of that fire history that I showed, and then this is like the last 10 years. So you can see the seasonality is completely different between the two. So I just figured I'd show that real quick.
Cool. Thank you.
Thanks, Inga.
Yeah, lots to learn and more to discuss about seasonality and climate impacts on fire. Madalena had a good question, which Inga addressed in the chat window. I'll repeat her question and ask Inga to just comment on it. She asked, what's the percentage of area where prescribed and wildfires both occurred? So Inga did answer with some hectare numbers in the chat window. But Inga, did you want to talk again, or Tom, about prescribed and wildfire and how commonly they occur in the New Jersey Pine Barrens?
So the wildfires occur, every spring of the year, March, April, May, that's typically the busiest time. The summer drought period depends on sometimes lightning strikes and of such. Prescribed fire seems to be fairly stable, just shy of 30,000 acres annually. So if you think about, the million-acre Pine Barrens, how we're covering on different rotations, we're probably, covering a couple 100,000 acres, somewhere in that neighborhood. So there's still a lot of untouched fuel out there that, needs to be managed.
Yeah, and I think, what did you guys do last year? Like 25,000 or 24,000 acres. That was for the whole state though, I think. But still, mostly the Pinelands.
Mostly the Pinelands, yeah.
Yeah.
100 acres in North Jersey, I think, yeah.
So, yeah, if you compare that to all of the area that I mean, it's 1 million acres in the Pinelands, right? But that includes some of the inland towns and things like that. So
I'll just chime in here too. There's about 2/3 of the acreage burned on the landscape presently for the past 15 years at least has been prescribed fire. And then 1/3 would be wildfire. And if you could think about the fuel structure that Nick and Inga talked about, and you know, that's part of why that might be changing. And then think back, you know, 100 years ago, quite the opposite was happening. All of the fire, for the most part, was wildfire, and maybe a small amount of prescribed fire on some agricultural land. So the timing of that fire and the type of fire has changed in dominance.
I think that understanding too that, you know, fire is fire in the landscape at some level. So we're making a large distinction between wildfire and prescribed fire. And I think that it's really dichotomous how prescribed fire has been implemented on the landscape in New Jersey traditionally versus what a running wildfire with a head fire would look like, right? So in a lot of cases, you're ending up with a high severity, you know, very intense running crown fire in some of these areas that have been fire excluded for many years. And sort of on the other side of the coin, you have prescribed fire that is really, we would think traditionally of this sort of backing fire that would be very easy to step over, that is burning, you know, 100 or 200 acres in a very similar way. And so understanding the forest structure in relation to those things, it seems kind of easy because one is very severe, having very large effects, and the other is not. But the reality is that those wildfires might have acted very differently in the past, and that we could also start burning a little bit differently with prescribed fire. And I think we started to do that also. So maybe it's more fire intensity than it should be. It's more of a gradient between the two than we're really giving credit for.
I think it's also worth pointing out that, you know, Inga highlighted that lightning strikes are a low percentage of our fires. And whether it's the current fire regime or the historic fire regime, we talk about wildfires, but when they were mostly caused by iron forges and railroads, they were still anthropogenic in source in one shape or form or another. So whether that previous fire regime was right or whether our current one is right is an interesting thing to chew on. But the current one is definitely safer.
So I'm seeing some really good questions come in on fire seasonality, and we unfortunately won't have time before the top of the hour to address everything. So I might need my panelists and a couple of our visitors to stick around after the top of the hour. But I do want to be sure we get to a couple more questions that had come in earlier in the chat window. The next question that popped up was for Mike. Madalena had asked, Mike, how do you use LIDAR to calculate the fire hazard near the houses? Is it based on the height of the tree only, a mix of tree height and the height under the layers, the vertical fuel continuity?
So yeah, that was from a paper in 2016. Nick was the lead author of that paper. And it was we used LIDAR and parcel data and a survey of homes that the state had done to basically clip the fuels in a LIDAR data set around homes. And we were looking at them in that one figure was within a 40-foot buffer around homes, which is the general guideline for how much fuel you should manage around your home. And so it was basically clipping those fuels to the area of the house and looking at canopy bulk density at different heights around homes and where they actually fell, whether the homeowner that would be impacted by the 40 feet of fuel around their house actually owned the fuel 40 feet from their house. And in a lot of our areas, you know, we have these small lots, or maybe the house is on one end of a larger lot, but 40 feet from where the house is isn't their property. And so we were able to demonstrate how, you know, that burden of fuel hazard that impacts homes often is not something that's manageable within the jurisdiction of the homeowner themselves. So yeah, I mean, maybe that's a longer answer than you need, but basically clipping fuels and LIDAR data by parcels and home footprints is how we did that, using canopy bulk density.
That's great. Thanks, Mike. And I think another question that had come in just reminds me, what Inga did not point out on the map is that Philadelphia and New York City are very much within the smoke shed for the New Jersey Pine Barrens. And so, yeah, do you want to talk about
Atlantic
that,
City. Yeah, I neglected to mention that New Jersey is the most densely populated state in the United States. So we're dealing with this, fire adapted ecosystem, surrounded by, a lot of people and very densely populated. So yeah, we have Philadelphia, we have New York City, we have Atlantic City, which is where a lot of the smoke goes when we try to do prescribed fires towards our eastern coast, where a lot of people vacation. So it's, the smoke management is also a very big issue here.
Great, thank you. In the last couple minutes before we formally close, and again, I'd love for my panelists to stick around afterward and anybody who wants to ask more questions. Karen had asked, and I'd like to pitch this to Tom. Karen asked, did the Atlantic white cedar wetlands contribute to wildfire spread and canopy fires?
In drought periods, it can, and lots of times during the dormant season, the fire goes into those wetland areas and it'll go out. But in droughty periods, there has been extensive damage done to the Atlantic white cedar in wildfires. Matter of fact, 1954, the Chatsworth fires started in a cedar swamp, and many starts were very common in that time period with the cedar cutters, the men that were cutting cedar in the swamps from smoking, and they used to have their water jugs were made of glass, so they had these rude vehicles that were down in the swamp, and the sun shining down there and would cause fires in their vehicles, and as such, the forest would be on fire.
Great, thank you, Tom. So we are now at like 30 seconds before the top of the hour. I really want to please join me in a virtual round of applause for all of our panelists for presenting and sharing all this information about the New Jersey Pine Barrens fire history and fire ecology. It's a tall task, and there's a lot more to learn. So we invite you to come on down to New Jersey, hopefully when it's safe to travel, and get a visit and get to see these pinelands for yourself. We have more of this workshop coming up over the next few days, and we are going to share a lot of materials on the North Atlantic Fire Science Exchange website. So please be sure to check that out, and make sure you subscribe to our newsletter to make sure you get any information that you otherwise might have missed. Huge thank you to our panelists. Thanks everybody for joining us from all the places you zoomed in from, and have a great rest of your day.